Hello, everybody. Tonight's list homework is going to be on solving root functions with roots on both sides. So that is what we are taking notes on for homework. And also, if you notice, the second part here says recall solving radicals involving quadratics. So we have a little experience from the last 2 days of notes and practice, and we're going to build on that knowledge as part of tonight's notes. So let's get started with these first two examples. Notice instead of a single radical in the equation, I have two radicals. Again, here there's two radicals. Let's start on number one. So the strategy for number one and number two, or the big idea, is that you want a radical on each side of the equal sign. So let's write a little note. Want a radical on each side of the equal sign before raising both sides to a power. So when solving root functions with roots on both sides, the key is that we want to have a root, whether it's a square root, third root, fourth root, on each side of the equal sign before raising both sides to a power. In number one, that's already been done for us. If I draw a line down my equal sign, it helps me to see each side. I have a radical, and there's one on each side. So we can go straight into our solving skills of clearing these roots by raising both sides to the second power. When we do that, we have 2x minus 5 equals x plus 4. We will be doing a check here, so I'm just going to make a space for that. I'm also going to put a little note here as a reminder why we do that. Remember that square root is the same as raising something to the 1/2 power. So if I'm trying to undo a square root or undo raising something to the 1/2 power, well, the only way that this 1/2 would become a 1 would be if I did this, because power we multiply, and 1/2 times 2, that equals 1. But we have to do this to both sides, and have to do this to both sides. No different than in Algebra 1, if you added 5, you did that to both sides, or if you divided by 10, you had to divide both sides by 10. If in the course of solving we need to raise one side to a power, we need to make sure we raise both sides. Back to the question at hand, we have 2x minus 5 equals x plus 4. Now we're back to our 9th grade solving skills. I have x present on both sides of the equation. We have a goal of getting x equal to some number. So I will use my math skills to gather anything that has a variable to the left side and anything that has a number to the right. So if I look here, 2x minus 5, well, 2x, that has a variable. It can stay. This plus 5, that can't stay. It needs to move. So I'm going to add 5 to both sides. Notice I choose to write the plus 5 under the plus 4 because those are like terms. My 5's cancel. I now have 2x equals x plus 9. Now on the right side of this equation, I just want numbers. So this x can't stay. The opposite of a positive x is a negative x, so I will subtract x from both sides. And 2x minus x is x equals 9. We have accomplished our goal of x equals a number. This is an even root. Even roots require checks, because I have to make sure that this is a possible answer, but I have to make sure that it doesn't create a negative under the radical. So let's do a check. We're going to substitute in 9 wherever we see x. So 2 times 9 minus 5. I'm using this as a guide right now, my original. So square root of 2x minus 5, all under the radical, equals the square root of 9 plus 4. The goal is that left will equal right. So I'm not going to move anything using math. I'm not adding or subtracting to either side. I'm simply going to use my algebra skills to simplify this on the left and then simplify the right, and hopefully they will come out equal. So under the radical, I have 2 times 9. That's 18 minus 5. And then over here, 9 plus 4, that's the square root of 13 here. And then 18 minus 5, that's the square root of 13, equals square root of 13. Check. That worked. So x equals 9 is the answer. Number 2 is the first example where we're going to have to do a little work first. So I'm going to give you a moment to compare what number 1 was originally and number 2 and see if you can figure out what's different. Well, unlike number 1, where I had a radical on each side of the equal sign, here both radicals are on the left side. So in number 1, I had this, a radical equals a radical. But when I look in this one, both radicals are on the same side of the equation. So before I do anything, I need to use that note we had written originally. We want a radical on each side of the equal sign before we raise both sides to a power. So I'm going to add this entire term to the other side. So I see that it says minus the third root of x minus 4. So I'm going to add the third root of x minus 4 to both sides. That leaves 2 times the third root of x on the left side, and now on the right side, I have the third root of x minus 4. Now I do have a radical on each side of the equal sign. Previously, when we were solving, we said to isolate the radical, but when we have two radicals, that step has changed to having a radical on each side. This 2 will stay. If I tried to divide both sides by 2, don't write this, what I'm writing. I want to show you, though, what it would look like. If I tried dividing both sides by 2, these 2's would cancel. I'd have the third root of x equals third root of x minus 4 divided by 2. That doesn't accomplish anything for me. So in this instance, when we're dealing with multiple radicals, as soon as you have a radical on each side, we're ready to clear it. If this is the third root, what is the inverse of the third root? Well, up here, to undo a square root, we raised both sides to the second power. To undo a third root, we will raise both sides to the third power. Exponent properties are going to come into play just a little bit right now, because this power has 2 places to go inside here. This is power of a product, because this says 2 times the third root of x. So the 3 needs to be sent here and here. This becomes 2 to the third. This 3 and the third root cancel. Leaving x behind. So if it helps you to gently cross out the 3 and the third root, go ahead and do that. The third root and raising to a power of 3 are inverse operations, which is why they cancel. If you want to go over this note again, we wrote right here. So in this instance, if we apply that note to this question, third root is the same as raising something to the 1/3 power, which is where we were here. We had a third root on the left and a third root on the right. Well, if I want 1/3 to become a 1 as a power, I have to raise it to the third power, which is the same as raising this to the third power. To keep our solving balanced, what we do to the left, we have to do to the right. Just as the third root and the power of 3 canceled here, the third root, or excuse me, the power of 3 and third root cancel, leaving x minus 4. 2 to the third is 8, so I have 8x equals x minus 4. Again, we have variables on both sides of the equation, so once more we will have a goal of x equals a number. When I look on the left, 8x, that's fine because I want x's on the left. But on the right side, I just want numbers. This variable x can't stay. So I will subtract x from both sides. So now I have 7x. I'm going to have to move this goal over. 7x equals -4. And last but not least, to finish solving, we will divide both sides by 7. X equals -4/7. Or, if we were going to round to 3 decimal places, let's see. 4. Let me grab my calculator. Don't have that in advance. 4/7. Would be -0.571. So either answer is acceptable. Remember, on the SAT, we need to round to 3 decimal places. So for decimal answers, we will always go to 3 places. This is an odd root question. So question for you guys, if it's an odd root, do we need to check? I'm hoping we're thinking and saying the answer is no. Odd roots do not have restrictions. Even roots, like this one was a square root, even roots do have a restriction. So we had to check. Odd roots have no restrictions, no check needed. Let's move into our recall questions. It says recall solving radicals involving quadratics. Let's jump right into number 3. We'll draw a line down the equal sign. So now we're back to a single radical in our equation, which means we're back to that first step of if we need to do work to isolate the radical, that has to happen first. So if I look on the side where the radical is located, it is not by itself. We have this positive x. Our first step will be to subtract x from both sides. So now I have the square root of 26 minus 11x equals, make that a little neater, (4 minus x on the right side. Now that the radical is by itself, we need to raise both sides to the appropriate power. So the inverse operation of square root will be raising both sides to the second power, because what I do to one side of my equation, I must do to the other. From here, I'm hoping our last couple of practice days are kicking in and we're knowing how to finish. So the square and the square root will cancel, leaving 26 minus 11x. Here, we've been stressing the fact that when there's subtraction, you cannot send in that 2. This means 4 minus x times 4 minus x. For those of you who are confident to finish it from here, please pause the video and complete number 3 on your own, and we'll check answers. Those of us who need a little help remembering, you can continue the notes with me. So make a choice. If you're confident to finish, press pause. Otherwise, stay with me right now. The left side will stay 26 minus 11x, and I'm going to use my arrows to distribute. So 4 times 4 is 16. 4 times negative x is minus 4x. Negative x times 4 is minus 4x. And negative x times the negative x is a positive x squared. So what I just wrote in blue comes from distributing. I see that I can combine like terms. So I will leave this 26 minus 11x alone. At the same time, I choose to rearrange this to be standard form, meaning that the x squared will come first. We're going to write it highest power to lowest. So x squared minus 8x plus 16. Reminder. Solving with quadratics need to get one side equal to 0. So as a reminder, when we're solving quadratics, we need to get one side equal to 0. Looking at each of these sides, technically I can move all of this to the left, but my priority is always to make sure that x squared stays positive. So I choose to move, using math, 26 and negative 11x, and I will do that in one step. The opposite of a positive 26 is to subtract 26. And ask yourself, where does it make sense to write minus 26 over here? Not here, not here, right here. And that's because these are like terms. So be strategic. Make sure you line up the like terms. And then the opposite of subtracting 11x, or the inverse operation, would be to add 11x. Again, I choose to be strategic and write plus 11x under the minus 8x because these are like terms. Draw my line all the way across. That's 0, 0, so 0 equals. And now I have x squared. Negative 8x plus 11x is plus 3x. And then a positive 16 minus 26 would be minus 10. Our first method of solving this is to see if we can factor. So here a is 1. Factoring. Recall that when we're factoring when a equals 1, I need factors of c. That add to b. So here, factors of negative 10, that's my c value, that add to 3. My first thought is 5 and 2. Because c is negative, I get to see if I want negative 5 or negative 2 to multiply to get a negative 10. To add to be a positive 3, 2 needs to be negative. So for my factors, it's going to be x plus 5 and then x minus 2. And that's prior knowledge, so I'm hoping we're comfortable with how we just factored that. To finish solving for x, once we factored, remember the idea is that there's some value of x that would make this first factor equal to 0, and 0 times anything is 0. And then there's a value of x that makes this factor 0. If this is 0, anything times 0 is 0. So to do that, we take each of these factors and set them equal to 0. We can use mental math to solve. Subtracting 5 from each side, I would get x equals negative 5. And then here I would add 2 to both sides, so I get x equals 2. We are not done though, because these are possible answers. We need to check both of them. We need to check because this is an even root And that's what all of this space over here is for. So let's check. The checks might seem to take a little bit, but as we do them over and over, you'll notice they take less and less time. We'll go back to our original equation as a model, and first I'm going to check x equals -5. So wherever I see x, I am plugging in -5. So it's 26 minus 11 times -5 equals 4. This right side will stay 4 the entire time. The goal is to simplify the left side, and hopefully it'll come out to be 4. So let's see. We have -5 plus. Underneath the radical, we have 26. -11 times -5 is a positive 55. Still working under the radical. 26 plus 55 is 81. Now that this is down to a single value, now I can actually think about taking the square root. This happens to be a perfect square. The square root of 81 is 9. So I have -5 plus 9. And then let's see, -5 plus 9 is 4. 4 equals 4. Check. Notice the entire time this stayed 4. So on your own, if you've kind of been avoiding your checks, you know who you are. No problem. Today is the day. So press pause and please show the check. This was the check for, let's give it a little bit of a title. Instead of just check, I'm going to write check x equals -5. So now you press pause and do the check for x equals 2. And then when you press play, I'm actually going to press pause as well. When you press play again, the entire check will be here, and we'll see if we match. So press pause, you check x equals 2, and then we'll come back and compare. And we're back. Here's my check of x equals 2, and it does work. So if our checks don't match, press pause again and see where something may have gone wrong. Again, when we're evaluating, the strategy is to continue to simplify what's underneath the radical to the very last possible moment when you get a single value, and then you take the square root. And notice, until that point, nothing else changed. I just worked on simplifying the radical first. All right, let's move on to number 4. Line down the equal sign. So before I jump into solving anything, I notice here that I am dealing only with a single radical. So that first step will be to isolate the radical. Ask yourself, what needs to move? Well, to get the square root of 2x by itself, this x has to move. The opposite, or the inverse of subtracting, is adding. So I will add x to both sides. On the left, I will now have x minus 4, or you could write -4 plus x, however you choose, equals the square root of 2x. Working with the quadratic questions is technically something we've done before, so if you're confident to continue working from here, please press pause and complete your work. If we need a little help, keep working with me now. So if you're still listening, it's because we need a little help, and that is okay. So let's talk about what we're going to do next. I'm trying to get rid of this radical sign. The inverse operation of square rooting would be to raise both sides to the second power. I say both sides because I can't just do this to one side. Technically, that clears the radical, but then it's unbalanced. What we do to one side of our equation, we must do to the other. Just like here, you added x to this side and the left side, we need to square both sides. As a reminder, you cannot distribute this 2 because it's subtraction. So x minus 4 all squared means 2 of these x minus 4s multiplied together. On the right side, this square cancels with the square root, leaving behind 2x, because the square root and squaring are inverses of each other. They're opposites. Using our arrows to distribute, x times x is x squared. X times negative 4 is minus 4x. Negative 4 times x, negative 4x. Move this over a little bit. So we just did negative 4 times x is negative 4x. And then last but not least, negative 4 times negative 4 is a positive 16. So what is written in green came from our distributing work. I see that I can combine like terms, so that's what I will do next. So I have x squared minus 8x plus 16. I didn't actually mean for that to be in green, so let me do that again. X squared minus 8x plus 16 equals 2x. Remember that note that we wrote on the other page? If we're working with quadratics, we want to have one side set equal to 0. Getting this side equal to 0 jumps out at me because all we need to do is subtract 2x from both sides. Now I have x squared minus 10x plus 16 equals 0, and I can factor. So I'm looking for two factors of 16, two numbers that multiply to 16 and multiply to a positive 16 and add to negative 10. So my first thought is 8 and 2. Remember, if C is positive, both factors are positive or both are negative, which is what we need to add to a negative 10x. So I'm going to keep going over here. So I get x minus 8 times x minus 2 equals 0. And from these factors, we get x equals 8, and then x equals 2. As a reminder, this is an even root, so we have possible answers. Let's check. So if you have been taking these notes with me, please pause and actually run the checks on your own. So let me clarify. We'll check x equals 8 first. Press pause. Doing the check of x equals 8, it'll be negative 4 equals the square root of 2 times 8 minus 8. Notice how I put a little end to the square root sign, and I make sure that by accident I don't write minus 8 underneath the radical. So this becomes negative 4 equals the square root of 16 minus 8. Negative 4 equals 4 minus 8. Negative 4 equals negative 4. Check. So x equals 8 worked out. Now let's check x equals 2. Maybe I can, if you can fit the check, let me see if I can move this over. Oh, it's going to take too long. All right, if you're able to fit your check of x equals 2 right here, I don't want to get into this workspace. Sorry, bear with me for a second. See if I can make this work out. I'm going to go for it. Check x equals 2. So that'll be negative 4 equals the square root of 2 times 2, close the radical, minus 8. So that's negative 4 equals the square root of 4 minus 8. Well, the square root of 4 is 2. And 2 minus 8 is negative 6. That is false. So x equals 2 is not an answer. X equals 8 is my only answer. So because x equals 2 came out to be false, we have to make sure we reject it. There is actually only one answer for number 4, not two answers. Okay, number 5. I'm at 30 minutes, so I'm only going to start number 5, and you'll finish. And then number 6 will fully be a you try. But I'll get you started on number 5. So I put a line down my equal sign so I can clearly see each side. The radical is already by itself, so I'll go straight to clearing this radical sign. The opposite of square rooting is raising to the second power. So I will square both sides. The square and the square root cancel, leaving behind x squared plus 5. Be a little neater there. X squared plus 5 equals x plus 1 times x plus 1. You finish from here. And then you try this one by yourself. And we'll start class tomorrow going over numbers 5 and 6. Great job. Any questions, please send me a reminder.